Okay, in this video, we're going to review everything that we've talked about as far as quadratic functions go. We're looking at this handout. First off, let's talk about what the parent function, your plain old f of x or y equals x squared, is the parent function with no pluses, minuses, multiplies, or negatives. This parent function is going to create a U-shaped curve that's called a parabola. That's the basic shape of a quadratic equation. The axis of symmetry is a vertical line that divides the parabola into two equal parts. The turning point, which is the lowest or highest point on the parabola, is called a vertex. Now let's remind you how to graph this parent function. We can find our vertex. The vertex of this parent function is always going to be at 0, 0. We can find a couple of points on each side, negative 1, 2, and 3, positive 1, 2, and 3. When you square these, here's what you'll get. And again, all I did there was plugged it into x squared. When x was negative 3, you get negative times negative is positive. As we plot these, here's what your parabola will look like. And there is your basic parent function, y equals x squared. Now let's go on, and then we talked about standard form. The standard form of a parabola, now we've got some extra stuff added on, was ax squared plus bx plus c. The axis of symmetry now can be found with the formula x equals negative b divided by 2a. And then in order to find the vertex, we're going to take that axis of symmetry, that x value, and plug it back in to find the vertex. Here's your first example. Let's find our axis of symmetry by plugging into negative b over 2a. Your b value is here. Your a value is 1. So that's going to be negative 4 over 2 times 1. So that's an x value of 2. That's your axis of symmetry is located at x equals 2. And there you see it on your graph. Your vertex is going to lie on that point. So you're going to simply plug that back in. And you can actually write it like this. Since it's not in f of x form, we're going to find y of 2 by plugging in 2 for x. That's going to be 2 to the second power minus 4 times 2 plus 1. That's going to be 5 minus 8, which is a negative 3. So your vertex is going to be at the point 2, negative 3. There's the lowest point on your graph. Since this is a positive 1, then that means your graph is going to cuff up. Then we're going to take points on each side, go down 1, and then let's go up 1. Let's plug those values into the exact same function, and there's what you're going to get. Once you plot these points, let's see, 1, negative 2, and again, you can always just mirror that across the axis of symmetry. Let's see, we have 0, 1, and you can mirror that across. Whoops, let's try it again. Move that point over 1. And then you plot all of those points, connect your dot, and there's your parabola graphed from standard form. Then you have what's called vertex form. And in vertex form, instead of the ax squared plus bx plus c, you have y equals a parentheses x minus h squared plus k. And again, the h and k would actually tell you where your vertex is by using your transformations. The a value is the exact same a value that you would have here. Again, tells you whether it's upside down or right side up, and it tells you how wide it is. Your axis of symmetry now is actually found from your vertex. Your vertex, this moves at right h and up k, so your vertex would be hk. And since your axis of symmetry passes through that vertex, your axis of symmetry would be x equals h, that exact same value. Let's graph this from vertex form. This plus 1 and plus 6 is going to move your graph left 1 and up 6. So that's going to be your vertex. Pick some points on each side. Let's do 0, 1, and 2 on one side, negative 2, negative 3, and negative 4 on the other side. We plug those values in, and there's what you get. And again, you can always look for patterns, down 2, down 6, down 10, and you have the same thing. It should be a constant pattern there. Let's plot those points, and then connect your dots, and there you see the basic form of your parabola.